Okay, in the last part I think we were discussing about moment distribution method. Particularly we were covering moment distribution for beams. Okay, in this particular lecture I want to talk about moment distribution for frames. Okay, in this particular lecture we'll talk about frames. Okay, in frames, before we proceed, I want to ask you whether you know the phenomena of sway. Okay, sway simply means that suppose you are having some frame here. Okay, suppose you are having some frame here, this is fixed here, this is fixed here. Suppose if I apply a vertical load here, okay, if I apply a vertical load here, the deflected shape of this frame will be something like this, isn't it? Will be something like this. Sorry. Okay, means that it will not move in the horizontal direction, isn't it? If you don't have a horizontal force, it is not going to move in the horizontal direction. On the contrary, suppose if I am having a frame like this, okay, suppose you are having a frame like this, instead of having this vertical force here, suppose you are having force like this. Okay, if you have a horizontal force like this, definitely your frame will try to sway. Okay, this type of horizontal deflection that takes place in your frame structure is called as your sway, this delta. Okay, so how will I judge whether my frame is going to sway or not? Because you have different analysis for sway frames and non-sway frames. Okay, if you have okay, symmetric loading, or if you are having bracings, okay, in these two conditions you can say that you will have your non-sway frames. Okay, for example, you can take many examples as you want. Okay, suppose in this frame structure you have fixed here, okay, and suppose the loading is something like this. Okay, so this type of structure is symmetric about your center, so it is not going to sway in your horizontal direction. Okay, there will not be any sway. This will be your non-sway frame. About this frame, suppose even if you are having a horizontal loading, suppose, okay, but if you are having some sort of bracing here, okay, some sort of bracing here that is not allowing your frame to move in the horizontal direction, then also you will have your non-sway frames. Okay, similarly if you have this type of loading, here you are having some load, here you are having some load, here you are having some P load, still if it is symmetric, you are not going to have any sway. Okay, so these are the cases that you can remember. If it is a symmetric loading or if there is any bracing, then there will not be any sway. On the contrary, if you think about it, if you have a frame like this, okay, if you have a frame like this, suppose my load is acting here, instead of center it is acting here, definitely your frame will sway in this direction. Okay, so this will be your sway frame. Okay, suppose if you have a structure like this, okay, suppose if you have a structure like this, okay, what can you say about this structure, sway or non-sway? Okay, so there is no symmetry, there is no bracing, so it is going to sway. Okay, this is your sway structure. Okay, there is no symmetry, it is anti-symmetric. Okay, so it is going to sway. Let's talk about analysis of non-sway frames. Okay, let's talk about the analysis of non-sway frames. How are we going to analyze it? It has no difference whatsoever with the beam structure. Okay, exactly what you used to do in beam, the same thing you have to do. Let us start with a very simple example. Okay, there is no difference. Whatever we did in beam, exactly the same process is valid here. Okay, suppose you have your frame is like this. You have fixed here. This is your point A. Okay, let this be joint B. Here also you have fix. Okay, let this be C, and you have some overhang here. Okay, D. Loading is acting on this one. Here you are having some loading of 10, length is 1.5. Okay, here you are having I inertia and UDL. Okay, UDL of 24. Okay, here you are having I inertia and this loading is 12. Okay, this is 1.5 meters, this is also 1.5 meters, and this horizontal length is 4 meters. This is your question. Okay, in question it will be asked to draw bending moment diagram and shear force diagram, but I am leaving it to your free body diagram only. I think you are comfortable drawing BMD and SFD on your own. Okay, so I am only going to solve for end moments. Okay, let's start with our process. Okay, first step is what? Same as that of beam. First you write the name of joints. You have 3 joints here. Okay, forget about this joint D. Why should I forget about this joint D? I have already told you, whenever there is an overhang, you forget about the overhang and you simply apply an imaginary moment like this equal to 10 into 1.5. Okay, and we can solve it from there. Okay, so I will not consider joint D as a joint. I will only solve joint A, B and C. Is it okay? Now draw a small table. Okay, so it will be better. Now second step is what? You have to write the name of your member. Member that you are having here is AB. Here I am writing BA, BC and CB. Okay, next step is distribution factor. Distribution factor, you can calculate distribution factor for, suppose AB is definitely 1. Okay, and CB is also 1, because from this joint you are having only one member, so it is definitely 1. You have to find distribution factor of BA. It will be stiffness of BA divided by stiffness of BA plus stiffness of BC, exactly what we did in beam. So it is 4EI. Okay, AB 4EI upon L is how much? 4 only, so it is 4EI by 4 plus this one is also 4EI divided by L is how much? 3 meters. If you solve this, you will get distribution factor as 0.43. Okay, so here I am writing 0.43. Sum should be 1, so this is definitely 0.57. Is it okay? Next thing that you have to do is you have to write your fixed end moment, FEM. Can you write the FEM of AB? UDL is how much? It is, I think, WL square upon 12. Okay, so here you will get W is 24, L is 4. Okay, so 24 into 4 square upon 12. Okay, I think you will get minus 32 here and plus 32 here. Okay, what about this value? Point load acting at center, BC. So it is PL upon 8 and PL upon 8. I think here you will get minus 4.5. You can calculate on your own. This is plus 4.5. Once you have your FEM, the next step that you have to do is you have to look if you have an overhang or a hinge, okay, or an end joint. Okay, in these cases, okay, in this particular case you are having an overhang. Okay, so you have to balance this joint B, because joint B will be having a net moment of 10 into 1.5 because of this overhang. So I think you will have a net moment of 15. So at this joint here, okay, I am doing it with red. At this joint here, I want this moment to be equal to plus 15. Okay, I want this moment to be equal to plus 15. Okay, what should I do? How much is it now? It is 32 minus 4.5, isn't it? It is 32 minus 4.5. Okay, 32 minus 4.5. So your moment now is 27.5. 27.5. I want this value to be 15. Okay, I want this value to be 15. So how much would I have to subtract with it? I think 27.5 minus 15. So I think I have to subtract 12.5 from this value. Okay, so this 12.5 I have to distribute among these two joints. Okay, are you able to understand? Because I want a net value of 15 at joint B, I want to somehow create 15 at this position. Okay, so I am having 27.5, but I want 15, so I have to subtract 12.5. Okay, this 12.5 will be subtracted from this joint and this joint. Okay, is it okay? From here and here you have to subtract. So how will you divide them? In the ratio of their distribution factor. Okay, so 12.5 is distributed, okay, in the ratio of their distribution factor, that is 0.43. okay, I think here you will get minus 5.37. okay, how are you getting this 5.37? 12.5 into 0.43. okay, 12.5 is what I have to subtract from here, and 0.43 is the distribution factor, and the right side you will have 12.5 minus 0.57. okay, so here you will have minus 7.12. okay, now if you sum them up, you will get a net value of, from this red circle you will get a net value of plus 15. Is it okay? You can calculate on your own. You will get a value of plus 15 from this red circle. Okay, and that is what our objective is. So this is your balancing step. Your next step is obviously your carryover step. So 5.37 will be distributed as, here you will get minus 2.68. okay, and here you will get minus 3.56. is it okay? Now you can sum them up. What is the value you are getting here? I think here you are getting minus 34.68. okay, and here you are getting 26.6 you are getting here, and here you are getting minus 11.6. if you sum them up, it is coming out to be 15, which is what was our objective, and here you are getting 0.93. okay, so this is your answer. okay, these are your end moments, final end moments that will occur. okay, now what you have to do, I am just giving you a hint, I am not solving entirely. Here you have this member AB. okay, now you know this value. This value is 34.6. okay, and this value is 26.6. you have your member BC, isn't it? B, you are having a value of 11.6. minus means anti-clockwise. okay, and here you are having a value of 0.93. okay, and obviously you are having your overhang here. okay, so here how much value will come? Here you will have a value of 15. okay, you should make sure that the value is 15. okay, okay, and here you are having your loading of, how much was the loading? I think it was 10. okay, here you are having 10. This is 1.5 meters. Here you are having your UDL of 24. This is 4 meters. okay, and here you are having a point load of 12. okay, this is 1.5. I am leaving it to you. What you can do here is you can find out these reactions. okay, you can find out these reactions, you can find out the reaction here, you can find out these reactions. okay, obviously you will be having some horizontal reaction also here. okay, so you can find out all these blue reactions by simply using equilibrium equation. okay, I am not going and doing everything, so you can solve on your own. Use equilibrium equation simply. Sigma Fy equal to 0. okay, sigma Fx equal to 0. okay, and sigma moment equal to 0. use these equations and get these blue reactions. okay, once you know these reactions, it is very easy to draw your shear force and bending moment diagram. okay. So this was your first problem. Suppose if we have a symmetric frame, let us solve one symmetric problem. okay, suppose you are having this type of symmetric frame. okay, this is fixed, this is also fixed, this is 4 meters, 4 meters and 4 meters. Here you are having some overhang, here also you are having some overhang, 40 and this is 0.5 meters, this is 0.5 meters, and this is 40. So as you can see about this axis, your frame is symmetrical. Okay, when your frame is symmetrical, you have slight advantage. Okay, what advantage you are having? That you don't need to solve the entire structure. If you can solve the half of this structure, okay, you know that the other half is going to have the same values because it is symmetric. Okay, so what I am going to do, I am only going to solve these two joints A and B. Okay, no more joints I need. I only need to solve these two joints A and B, and I can know all the values in the frame. Now first step is writing the value, the name of joints. You have A, B, that is all I need. Okay, now prepare a small table. See how the problem is reduced to a very small problem. Okay, this is joint A, joint B, this is your member AB, BA. Here you will have some BC. Okay, suppose this is your A, B and C. We don't need C, but I am just showing you that C is here. Okay, now distribution factor. Here you have to be very careful. Okay, many times you will make a mistake here. Okay, so be very careful. Since you are making use of symmetry, okay, since you are making use of symmetry, what is the distribution factor of BC? Distribution factor of BC is KBC upon KBC plus KBA. Okay, what is KBC? KBC is, I am writing it, see, 2EI upon 4. 2EI by L. I have already told you in the first lecture, whenever you are making use of symmetry, this beam that is passing through this symmetrical plane will have a stiffness of 2EI by L, not 3EI by L, not 4EI by L, 2EI by L if you are making use of symmetry. If you are not making use of symmetry, you are solving the entire structure, then you can go for 4EI by L. Okay, so I am making use of symmetry, so I am going for 2EI by L. KBA is normal, it is 4EI by L. So you can find out these values. I think it will come out to be 0.67. Okay, 0.67 here. This is obviously 1 and 0.33 here. Next step is your fixed end moment. Okay, I am rubbing these values. So be very careful what stiffness value you have to use where. Okay, fixed end moment, if you look closely at AB, you are not having any loading, so fixed end moment is 0. BA is also having 0, BC is also having 0. Is it okay? There is no loading on BC also. There is no loading on BC, there is no loading on AB. Okay, just this overhang is there, and this overhang is giving a net moment of minus 40 into 0.5. Why minus? Because it is anti-clockwise. Okay, so I think minus 20 kilonewton meter this moment is coming at joint B. Okay, at joint B, here you can see it is 0. Okay, you have to somehow make it minus 20. How will you make it minus 20? Okay, what you do, you divide this minus 20 as 20 into 0.67 and 20 into 0.33. Is it okay? So I think here you can write 13 minus 13.33 and minus 6.67. If you look closely now, this joint is having a net moment of minus 20. Okay, that is what was our objective. Now the next step is very simple. Just one step question is there. This is just a carryover. You don't need to care about this value. No need to care about this value. We only need this value. This is half of 13.33. I think it is 6.67 something. Okay, sum them up. What is the value you are getting here? You are getting minus 6.67 here. Here you are getting minus 13.33. Isn't it? Here you are getting minus 13.33. Now you will ask me what is the value here. Here you can write the value as minus 6.67. Is it okay? Minus 6.67. Okay. What about the other part of the structure? It is symmetric, right? It is symmetric. So you have this here, and this here, right? I have found out that here you are having moment like this. Okay. Here you are having moment like minus 13.33. So it is 13.33 anti-clockwise. Here also you are having 6.67. It is symmetric about this axis. So obviously the moment on the other side here it's going to be 6.67. Okay, here it is going to be like this 13.33, and here it is going to be like this 6.67 because it is symmetric. So the exact same values will be present on the opposite side. Okay, what about your overhang? Okay, your overhang is going to be having, this is 40, this is 0.5, so obviously your overhang will be having a moment of 20 like this. Okay, rest reactions you can find out on your own. I am not going into that. You can use equilibrium equation, get these reactions here, whatever reactions are coming, okay, whatever horizontal and vertical reaction will come, that you can evaluate. Okay, that you can do it on your own. Okay, just use the equilibrium equation and find out these black reactions. Okay, this is how you solve a symmetric problem. Okay, one more problem I want to solve where people usually get confusion. Okay, I am only solving problems where you may or may not get confused. Suppose your frame is like this, okay, and you are having some bracing here. Okay, you are having some bracing here, and here you are having some overhang. This value is 2, this is 1.5. Some UDL is acting here. Okay, UDL value is 15, inertia is 3i. Here value is 1.5, inertia is 3i. This is length is 2.5, inertia is I. Okay, here the value is 2i and the length is 4. Okay, and this is your fixed support. This is your question. Okay, obviously this leg is larger than this one. It is, okay, this leg is 4 meters, so it is certainly larger than this. It will come somewhere here. Okay, something like this. You have to find the end moments. Now here you will have a very big confusion. Okay, suppose I am naming the joints first. This is your A, B, C, D. Okay, I don't need this overhang, E, and your F. Okay, first step is to write the name of your joint. You have A, B, isn't it, C, and D. That is it. That is all I need. Okay, or what I can do here is, okay, there are many ways to solve this. Either you can take A, B, C and D, or I will show you a little difficult way to solve this. Okay, you can either take E, B, C and D you can take. Okay, F is obviously not required, it is overhang. I am not considering this part, this leg. Okay, I am not considering, and the reason I am not considering this leg is, suppose you have a leg like this. Okay, if I solve this much, I will get this moment, isn't it? I will get this moment. How I will get this moment? Okay, this is your E, this is your B, isn't it? And this is going for your A, and this is further going here. Okay, if I solve this, what we are solving here is, okay, if I solve this, I will get what I will get. I will get this moment and I will get this moment, but this B point is having net moment 0. Okay, I can use that property and I can get this moment also, isn't it? This moment also I can evaluate. Once I know this moment, I know that the carryover factor is half, and the moment that you will get here is m by 2. Okay, so I already know the moment at A once I know the moment at B point. Okay, so I don't need to consider joint A here. Okay, that is the special thing in this question. Okay, the approach. Okay, otherwise if you like it, you can solve all joints, but it will be lengthy. Okay, now you can draw a table. Okay, suppose you have your member. This is your EB, BE, BA is not required, BC is required, CB, CD and DC. Is it okay? Distribution factor you can calculate. Okay, I am not writing any distribution factor, but suppose I am writing distribution factor of EB. What will be distribution factor of EB? It is KEB divided by KEB plus KBC plus KBA. Okay, because of this B joint is having three different, sorry, this is KBE, okay, this is not KEB. KEB is DFEB is obviously 1. This is KBE, okay. KEB is already 1. This value is already 1. If you evaluate like this, these all values are 4 EI by L only, okay. If you put all the values and evaluate, you will get this value as 0.63, this value as 0.24, say, okay, 0.24. Here you will get 0.6 and here I will get 0.4. Now many people make a mistake here, okay. You look closely here. Many people think that the sum of these two values should be equal to 1, but it is not so in this case, because you have not considered this arm BA, okay, BA arm you have not considered. Because of that, the sum of these two is not going to come equal to 1. It will come something less than 1, because distribution factor of AB is not considered here. So don't make that mistake, okay. This you should be careful about. It is not going to be equal to 1, so don't get confused, okay. Now fixed end moment, okay, fixed end moment. What is the fixed end moment for BE? I think it is 0. Here also 0, okay. Here you will get WL square by 12, so you have minus 20 here and plus 20 here, and here also you are having 0. Now in the next step you should look if you have any overhang. Yes, you are having an overhang, so you are having at C joint, okay, at this joint C you are having a net moment of 3 clockwise, okay. So somehow this 20 is present here. I want to make this 3. To make it 3, I want to subtract 17 from 20, okay. So this minus 17 I have to distribute here and here, okay. In what ratio should I distribute it? In the ratio of 0.6 and 0.4. So you have 17 into 0.6, 17 into 0.4, you will have here minus, I think you will get here 10.2 and 6.8. This is 10.2 and this is minus 6.8. So I am writing here minus 10.2, okay, and this is minus 6.8. If you sum these value up, I think you will get it to be 3. Is it okay? And I wanted it to be 3. What is the next step? The next step is your, okay, first of all let's balance B simultaneously, okay. B also we can balance simultaneously. It is having minus 20, so I have to provide plus 20. I have to divide it here and here. In what ratio I will divide? I will divide it in the ratio of distribution factor. So 20 into 0.63 and 20 into 0.24, okay. So I think you will get 12.6 and 4.8, okay. So here you will get 12.6 and here you will get 4.8. If you check this value entirely, it will come out to be 0, okay. So that it has been balanced, okay. अब कैरी ओवर स्टेप आएगा अगला, तो यहाँ पे कैरी ओवर कर लो 6.3, आधा इसका, ठीक है. इसका कैरी ओवर यहाँ जाएगा, इसका कैरी ओवर यहाँ जाएगा, ठीक है, और इसका कैरी ओवर तुम्हारा यहाँ जाएगा, ठीक है. तो ये वाली वैल्यू मेरे ख्याल से 2.4 आ जाएगी, ये माइनस 5.1 आ जाएगी और ये वाली वैल्यू माइनस 3.4 आ जाएगी, ठीक है. अभी हमें कंटिन्यू करना पड़ेगा क्योंकि अभी ये वैल्यूज़ बहुत बड़ी हैं, ठीक है. अब यहाँ पे माइनस 5.1 आ रहा है, तो मुझे इसको ज़ीरो करने के लिए प्लस 5.1 देना है और उसको मुझे प्लस 5.1 को मुझे डिस्ट्रीब्यूट करना पड़ेगा 0.63 और 0.24 के रेशियो में, ठीक है. तो देखना मैं डिस्ट्रीब्यूट कर रहा हूँ, तो ये वैल्यूज़ आ जाएगी 3.21, ठीक है, और यहाँ पे आ जाएगी 1.22, ओके. मेरे ख्याल से इसको देखोगे तो ये पूरा ज़ीरो हो जाएगा, ठीक है. यहाँ पे 2.4 है, ठीक है, यहाँ पे 2.4 है. इसको अगर तुम ज़ीरो करने की कोशिश करोगे तो कितना आ जाएगा? यहाँ पे आ जाएगा 0.6 और 0.4 के रेशियो में इसको तोड़ दो 2.4 को, तो आ जाएगा माइनस 1.44 और यहाँ पे आ जाएगा माइनस 0.96, ठीक है. अगला स्टेप कैरी ओवर है, तो इसका कैरी ओवर जाएगा यहाँ, इसका यहाँ और इसका यहाँ, ठीक है. 3.2 का कैरी ओवर हो जाएगा 1.60, यहाँ का कैरी ओवर हो जाएगा 0.72 माइनस का, और यहाँ का हो जाएगा 0.61, 0.96 का आ जाएगा माइनस 0.48, ठीक है. मेरे ख्याल से तुम समझ रहे हो कैसे करना है. इसी को तुम कंटिन्यू करते रहना जब तक ये वैल्यू तुम्हारी काफ़ी छोटी ना हो जाए, ठीक है. जब तुम 1-2 आइटरेशन और करोगे तो फाइनली तुम्हारे मोमेंट्स आ जाएंगे यहाँ पर 8.125 आ जाएगा ये वाला प्लस में, ठीक है। ये वाला आ जाएगा तुम्हारा 16.37, ठीक है। ये वाला आ जाएगा -19.77, ठीक है। और ये वाला आ जाएगा तुम्हारा 11.05, ठीक है, -7.94, ठीक है। और ये वाला -4, ठीक है। ये तुम्हारे एंड मोमेंट्स आ जाएंगे, ठीक है। अब ध्यान से देखना हमें क्या क्या मिल गया, ठीक है। अगर तुम फ्री बॉडी डायग्राम बनाओगे अपने उसका, ठीक है, ये एक मेंबर यहाँ पर है, यहाँ पर तुम्हारा ओवरहैंग है, फिर एक मेंबर यहाँ पर है और एक मेंबर यहाँ पर है। ओवरहैंग नहीं है, फिक्स है ये, ठीक है। तो हमें ये वाला मोमेंट मिल गया एक तो ई बी, ये वाला 8.25 यानी क्लॉकवाइज आ रहा है, तो 8.125 ये मिल गया हमें। ये भी क्लॉकवाइज है 16.37, ठीक है, ओके। तो ये -16.37 ये आ गया। उसके बाद ये बी सी पे दिया हुआ है 19.77, तो ये 19.77 हो गया तुम्हारा। और यहाँ पर 11.05 क्लॉकवाइज, तो 11.05 -7.94, तो ये वाला तुम्हारा आ जाएगा 7.94। और यहाँ पे तुम्हारा आ जाएगा 4, ठीक है। अब तुम कहोगे कि मुझे बी ए का मोमेंट तो पता ही नहीं चला, ठीक है। तो बी ए का मोमेंट तुम निकाल सकते हो। यहाँ पे देखो ये पॉइंट और ये पॉइंट, ये तीनों बी हैं, और बी पॉइंट का नेट मोमेंट कितना है 0। ये ऐसा तुम्हारा बी पॉइंट है ये, ठीक है। इस पर कोई नेट मोमेंट तो लगा नहीं है एक्सटर्नल, तो इसका नेट मोमेंट जो सम करोगे बी ई बी सी और बी ए का, वो 0 आना चाहिए। यानी मोमेंट ऑफ बी ए, मोमेंट ऑफ बी सी और मोमेंट ऑफ बी ई तीनों मिलकर 0 आने चाहिए, ठीक है। मोमेंट ऑफ बी ए तुम्हें पता है, ठीक है, ये है बी ए 19.77, माइनस में लिख दे रहा हूँ, -19.77। बी सी तुम्हें पता है, बी ए ये है तुम्हारा, बी ई तुम्हें पता है ना, बी सी, ओके 16.37, तो ये तुम्हारा +16.37 प्लस एम बी ए इज इक्वल टू 0। तो मेरे ख्याल से एम बी ए तुम्हारा कितना आ जाएगा, इन दोनों को माइनस कर लोगे तो तुम्हें एम बी ए मिल जाएगा, ठीक है। 19.77 माइनस 16.37, 3.4 आ जाएगा प्लस का मतलब क्लॉकवाइज। तो यहाँ पे तुम्हारा 3.4 कुछ ऐसा लगा हुआ है, और अगर तुम्हारा 3.4 यहाँ पे ऐसा लगा हुआ है, तो इसका रजिस्ट करने के लिए 3.4/2 यहाँ पे यानी 1.7 यहाँ पे आ जाएगा, ठीक है। सारे एंड मोमेंट्स से पता चल जाए सारे मेंबर्स के, तो तुम रिएक्शन निकाल सकते हो अपने आप, ठीक है। रिएक्शन तुम निकाल लेना इक्विलिब्रियम क्वेश्चन यूज़ करके, और फिर उसका बेंडिंग मोमेंट और शियर फोर्स बनाते हैं। मेरे ख्याल से नॉन स्वे फ्रेम समझ गए होगे। एक क्वेश्चन हम लोग स्वे पे भी कर लेते हैं, स्वे फ्रेम, इवन दो गेट पॉइंट ऑफ व्यू से बिल्कुल इंपॉर्टेंट नहीं है, कभी भी नहीं आएगा, ठीक है, सिर्फ ईएस पॉइंट ऑफ व्यू से इंपॉर्टेंट है। स्वे फ्रेम्स हम देख लेते हैं कैसे सॉल्व करेंगे। वर्किंग अप्रोच, ठीक है। सपोज तुम्हारे पास एक फ्रेम है, ठीक है, स्वे करता है, ठीक है। स्वे कर रहा है मतलब ना तो उसके पास ब्रेसिंग है और ना ही उसके पास सिमेट्रिक लोडिंग है, ठीक है। कुछ लोड लगा हुआ है यहाँ पे पी का, P1 मान लो इसे, और यहाँ पर और फोर्स लगा हुआ है P2, तो ये डेफिनेटली तुम्हारा स्वे फ्रेम है, ठीक है। अब एनालिसिस हम इसकी ऐसे करते हैं कि हम इसको दो पार्ट्स में तोड़ लेते हैं, ठीक है। क्योंकि हमें नॉन स्वे फ्रेम की एनालिसिस करना आता है, अभी हम नॉन स्वे फ्रेम की एनालिसिस करके आए हैं, क्योंकि हमें नॉन स्वे फ्रेम की एनालिसिस करना आता है, हम इसको एक नॉन स्वे फ्रेम में ही तोड़ लेते हैं। कैसे तोड़ेंगे नॉन स्वे फ्रेम में, ठीक है। मान लो कि ये इस तरफ स्वे करने वाला है, ठीक है, तो मैं क्या करता हूँ, मैं इस जॉइंट पर एक फोर्स लगा देता हूँ आर का, ठीक है। इस जॉइंट पर मैं एक आर का फोर्स लगा देता हूँ, या तुम इसको ऐसा मान लो, ऐसा मानने की बजाय तुम इसको ऐसा मान लो कि मैं इस पॉइंट को पिन जॉइंट बना देता हूँ, ठीक है। अब तो ये स्वे नहीं करेगा, अब तो इसने पकड़ के रखेगा जॉइंट इसको, तो ये तुम्हारा नॉन स्वे हो गया, ठीक है। अब मैं क्या करता हूँ, अब तुम अपनी लोडिंग को भूल जाओ, सेकंड पार्ट में, ठीक है। यहाँ पे तुम क्या करो, मान लो कि यहाँ पे रिएक्शन आ रही होगी, कुछ इस तरफ स्वे कर रहा होगा तो ये रिएक्शन तुम्हारी इस तरफ आ रही होगी। तुम क्या करो, एक एस अमाउंट ऑफ फोर्स यहाँ पे लगा दो और इसकी एनालिसिस तुम कर लो, ठीक है। ये कुछ इस तरीके से डिफ्लेक्ट कर जाएगा, ठीक है। डेल्टा मान लो इसको और इसकी एनालिसिस कर लो। यहाँ से तुमको आर पता चल जाएगा, ठीक है। यहाँ से तुमको आर पता चल जाएगा और मैं कहूँगा तुम्हें नॉन स्वे मोमेंट्स पता चल जाएंगे, नॉन स्वे मोमेंट्स, ठीक है। अब इसे सुन लो, जब क्वेश्चन करेंगे तो क्लियर हो जाएगा बिल्कुल। यहाँ से तुम एस निकाल लेना और तुमको स्वे मोमेंट पता चल जाएंगे, ठीक है, ठीक है। अब तुम्हें क्या करना होगा, यहाँ पे एक करेक्शन फैक्टर तुम्हें लगाना होगा, ठीक है। क्योंकि ये एस अमाउंट ऑफ फोर्स के लिए स्वे मोमेंट आए हैं, हमारा एक्चुअल फोर्स आर है, तो तुम्हें क्या करना पड़ेगा, जो भी यहाँ पे स्वे मोमेंट्स आएंगे उनको आर बाय एस का करेक्शन फैक्टर तुमको देना पड़ेगा, ठीक है। लास्ट में तुम्हारे जो नॉन स्वे मोमेंट हैं, ओके, उसको तुम क्या करोगे, ठीक है। अब तुम आखिरी में क्या करोगे, तुम्हारा टोटल मोमेंट जो हो जाएगा, टोटल मोमेंट वो हो जाएगा ये नॉन स्वे मोमेंट जो आया था यहाँ से वो, प्लस ये जो करेक्टेड मोमेंट आया था यहाँ पे वो, ये तुम्हारा टोटल मोमेंट हो जाएगा, ठीक है। ये तुम्हारी वर्किंग अप्रोच है। एक बार और रिपीट कर देता हूँ मैं, जो भी तुमको स्वे फ्रेम दिया हो उसको तुम दो पार्ट्स में तोड़ लेना, एक नॉन स्वे और एक स्वे, ठीक है। नॉन स्वे के लिए तुम क्या करना, यहाँ पे एक पिन जॉइंट मार देना ताकि ये इसे मूव करने नहीं देगा हॉरिजॉन्टल डायरेक्शन में, ठीक है। इसकी हेल्प से तुम इस फ्रेम को सॉल्व कर लेना जस्ट लाइक नॉन स्वे फ्रेम, ठीक है। नॉन स्वे फ्रेम की तरह का सॉल्व करके तुम रिएक्शन आर निकाल लेना, ठीक है, रिएक्शन आर निकाल लेना। और यहाँ पे जाके तुम क्या करना, स्वे फ्रेम में तुम एस निकाल लेना, ठीक है, एस निकाल लेना। उसके बाद यहाँ से तुम्हें नॉन स्वे मोमेंट मिल जाएंगे और इस वाले स्ट्रक्चर से तुम्हें स्वे मोमेंट मिल जाएंगे। उस पर तुम्हें करेक्शन फैक्टर लगा देना आर बाय एस का, ठीक है, और इन दोनों का सम कर लेना तो तुमको टोटल मोमेंट्स मिल जाएंगे। ये तुम्हारी वर्किंग अप्रोच हो गई स्वे फ्रेम्स की। पर स्वे फ्रेम्स बिल्कुल भी इम्पोर्टेंट नहीं है, बहुत कम चांसेस है कि पेपर में आएंगे। क्वेश्चन सॉल्व मैं नहीं कर रहा हूँ, अप्रोच मैंने तुम्हें बता दी है, ठीक है। तुम खुद क्वेश्चन सॉल्व कर सकते हो किसी बुक से, अप्रोच तुम्हारी यही रहेगी, ठीक है।